So you guys have already finished problems numbers 1 through 4. This is part 2 of the alkane-alkene packet. And you'll notice that these have double bonds in them because we're looking at alkenes. So what we're going to do is we're going to go through number 5 together, and we're going to go through number 7 together. And then what I'd like you to do is to pause, and then I'd like you to finish number 6 and 8, and then of course you can come back and you can see the solution. So going through the rules, we need to find the longest parent with the double bond. So if we go across, you'll see we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Is there a larger carbon compound that we can find that has the double bond? Let's try going down. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Going either of these ways would give us the 6 carbon, and it's going to be the same either way. So we'll go ahead and we're going to box this in like this. Here's our longest carbon. And again, it's a 6 carbon, so it's going to be a hex. It's going to be a hexene because it's an alkene. So now what we need to do is we need to number the bonds. Do we number them down below? 1, 2, 3, 4, 5. Or do we number them this way? 1, 2, 3, 4, 5. Remember, we want the double bond to be the lowest number, so we need to number the bonds in this direction. 1, 2, 3, 4, 5. So we now number the carbons in the same direction. 1, 2, 3, 4, 5, and 6. I'm going to go ahead and circle my side groups. I've got a 1 carbon, and that's going to be my methyl group. And I also have two carbons, and these are going to be my ethyl groups. So which of these is going to get written first, ethyl or methyl? Remember, they go alphabetically, so the ethyl is going to be written first. We're also going to be having 2 of them, so it's going to be diethyl. And they're both attached to 3, so this is going to be 3,3-diethyl. 3,3 dash di for the 2, ethyl dash. Now where's the methyl? The methyl is actually at carbon 2, so it's going to be 2 dash methyl dash. Where's the double bond? The double bond is also in the second position. 2 dash hex, and it's going to end in E-N-E. 3,3-diethyl, 2-methyl, 2-hexene. We can turn the page, and we can do number 7 together. Draw 3-ethyl, 2-methyl, 1-hexene. So this is a little bit easier. So we have hex, which means we have a 6-carbon parent. So we can go ahead and draw 6 carbons. 1, 2, 3, 4, 5, 6. Where's the double bond going to be? It's going to be in the first position. So we're just going to make that into a double bond right there. Let's go ahead and now number the carbons. 1, 2, 3, 4, 5, 6. I guess we can also number the bonds, but we've already labeled the position. 1, 2, 3, 4, 5. So I have a methyl and I have an ethyl. So at number 3, I have an ethyl. How many carbons is ethyl? Me-PB. It's the second. E is the second. So it's going to be a 2 carbon. Methyl is going to be a 1 carbon. So the 2 carbon is going to be attached to number 3. So we'll go ahead and we'll put it up here. 1, 2, like that. The 1 carbon is going to be attached to the second one. And we can put it either up or down, but just to avoid the numbers, I'm going to put it in the up position like that. So that's 3 ethyl, 2 methyl, 1 hexene. So what I'd like you to do now is to press pause and go back and see if you can finish problems number 6 and problem number 8. And then you'll be coming back and we'll conclude that. Okay, hopefully you have finished or at least attempted problems 6 and 8. If you're just copying these, it's not going to provide you with the proper practice, and you'll not be getting the proper experience. So let's go ahead and see if we can find the longest chain here. 1, 2, 3, 4, 5, 6, 7. We also have 1, 2, 3, 4, 5, 6, 7 in this way. This is actually a special type of carbon bond where they're branching off of each other. So I'd rather simplify it by making the chain go in this direction, like this. That also has 7. It's going to be easier to name it that way rather than going up like that. So we have the 1 position for the bond here and the 2. If I started from this direction, 1, 2, 3, 4, 5, the double bond would have a number 5. So we want the double bond to have the lowest number. And the carbons will also be numbered in the same direction. I just do the 5 down here because it's where there's some spaces. And I have a methyl. And I have 2 ethyls. So if you remember, when you have 2, you have to use tri. If you have 3, you have to use, or 2 is di and 3 will be tri. Let's go ahead and name this. So of course the ethyl gets written first, and we have to find out what numbers that they're attached to. They're attached to carbons numbers 4 and 5. So this will be 4, 5 dash di for the 2 ethyls that we have. So it'll be diethyl dash. Where's the methyl? The methyl is located at 6 methyl. And lastly, where's the double bond? It is in the second position. So it's going to be 2. And for a 1, 2, 3, 4, 5, 6, 7, this is going to be a, not a sept, but a hept, heptene. Okay, if you go to the last page, so we have 3 ethyl, 4 methyl, 2 pentene. So pentene, pent means it's going to be a 5 carbon, and attached is going to be a 1 carbon and a 2 carbon. Let's go ahead and draw the carbons. 1, 2, 3, 4, 5. The double bond is going to be found in the second position, right here. Let's go ahead and number the carbons. 1, 2, 3, 4, 5. Attached to number 3 is going to be a 2 carbon, 1, 2, and attached to 4 is going to be a single carbon. We could have drawn those down there. We could have drawn the 2 down there as well. That's it.